Okay, so today we're going to be talking about proportional relationships and specifically direct variation. Some of this is going to be a review from not only 6th grade, but 7th grade also. And then we're going to kick it up a notch with direct variation for this year, okay? So first, I want to go back and review the basics. In 6th and 7th grade, 6th grade you really started looking at just the basics. Is something proportional or not? And we were looking at, did the graph go through the origin or not go through the origin? So in 6th grade, it was real basic. 7th grade, we kind of got into unit rates. We got into, in 6th grade, we did unit rates as well. We got a little more specific. Well, now in 8th grade, we're going to get even more detailed, talking about proportional relationships, okay? So the first thing we need to remember is, what are the characteristics of a proportional relationship? Well, first thing we know, it's linear. Does anybody know what linear means? A straight line. So linear, if you notice, it has that root word line in it. So it really translates to straight line. And specifically in our case, we're talking about when it's on a graph. Remember how functions, they could be curvy, they could be a V. Well, in a linear relationship, it's just a straight line. Whichever way that line goes, it's one straight line. That means it is linear. Also, because it's proportional, if you remember back to 6th grade, that line on a graph will always go through the origin, which is, we know, the point 0, 0. The other thing, and this is reaching way back to 6th grade, 6th grade you talked about multiplicative and additive relationships. A proportional relationship is multiplicative, means it uses, and that should not say equation, uses the operation of multiplication. Just like the word multiplicative has that multiply kind of root word, means multiplication. But I told you this year we're going to get a little bit more detailed in how we look at proportional relationships. So one of the newer vocabulary words this year is going to be direct variation. And it's just a fancy way to say that something is proportional. If we look here at the first bullet point, direct variation is another way of describing a relationship between x and y, and we're using x and y because you know graphs are x coordinates, y coordinates. So when that relationship of x and y, when it is proportional. So when that line is proportional, when it goes through the origin, we say it has a direct variation. It directly varies. Remember when we talked about, what does the word proportional mean? It kind of means equal, right? It's the same. Remember when we did equations? Equations have to be proportional. They have to be balanced. What you do to one, you do to the other. Well, that's kind of like how a proportional graph works. What happens to x causes the y. Okay? So it's a direct variation. Y is a direct variation of whatever you're doing to that x coordinate. Remember back when you had to do process tables, you had to do an XY table, and you had to figure out the rule? That's what we're talking about. It directly varies. The y, your answer, is a direct result of what you did to x. All right. Also, in a direct variation, one variable will always be a constant multiple of the other. And that's just another way to say we're using multiplication. 2 times x, 3 times x, 4 times x. That x value, whatever you did to it, you have to multiply it to get the y. But now let's review constant of proportionality. You talked about this last year, but I know most people kind of forgot. Constant of proportionality is represented by the variable k. So when you see a variable k in an equation, you know that is a constant of proportionality. That means constant means the same. Proportionality means it's proportional. That is the same reason why that graph is proportional. So situations that vary directly, or you could say situations that are proportional, can always be represented with the equation y equals kx. And if you notice, that's the same thing as saying y equals k times x, right? Remember, up here we said we're going to use the operation of multiplication right here, k times x. To solve for k, to find that constant of proportionality, to solve for k, I am going to divide the y value minus the x value. So k is equal to y divided by x. Now, I didn't do anything fancy to get this second equation. All I did, if I took this first equation, y equals k times x, and I want to solve for the constant of proportionality, meaning I want to solve for k. In an equation, to solve for something, that means I got to get it by itself, right? Well, if this says k times x, how do I undo that to get rid of that x? Divide by x, divide by x. That cancels out. That's where we get that second formula. K is equal to y divided by x. So I didn't just do anything fancy. I just moved it around so that way it's easier. If I'm trying to find out what is that constant proportionality, I can just already have that formula moved around. Now, last year, you talked about constant rate of change. Do y'all remember that? Constant rate of change? Like what you did to the x, it was constant every time to get that y, that constant rate of change. Constant rate of change. And in 6th grade, you learned about unit rates, right? That's where you first learned about unit rates. And we could find a unit rate by looking at a graph. A unit rate, remember, is where you're trying to find the value of just one of something. Like if it was 50 miles per hour, that would be my unit rate for 1 hour. Well, the reason why I'm writing this down here is because finding the unit rate of something is finding its constant of proportionality. But in 6th grade, remember I said we were just barely looking at these, so we just focused on unit rate. Last year, we looked at the constant rate of change. We filled out that table and saw what it did. We made the graph and had to make it keep going, plotting the points. So we were looking at how did that graph change as it went on. This year, we're really getting specific and we're looking more in detail about proportional relationships. So we just call it the constant of proportionality. But they all mean the same thing, okay? And I'll be able to show you that on the inside examples of how they all are really the same thing. We're just a little more sophisticated now with our vocabulary, okay? All right, so let's, down here at the remember. I want to give you 2 little tips that will help you because you know they like to give you word problems, right? And sometimes they're kind of hard to break down. So I want to give you 2 little tips that will help you. The first tip is that when you're dealing with money, money is always a Y value. Money is always a Y value. And for those of you that had me last year when we were solving ratios, didn't I tell you money always goes on top? I did. I told my students last year, if you're setting it up, yep, money goes on top. Well, I was trying to set that up because here, look, constant of proportionality, your Y value goes on top. And money is always a Y value. It's always dependent. How much money something costs, it always depends on what you buy. Okay? Another little trick, time is always an X value. Time is always an X value. Whether it's weeks, months, years, days, hours, seconds, every 3 weeks, it's a length of time. So when you have a graph and you have a proportional relationship that goes through the origin, if we're talking about money, your money will always be labeled on your y-axis. Time will always be labeled on your x-axis. It's just a little tip. It's not a requirement to know, but it can help make things a little bit easier. All right, so here the question is wanting us to determine the constant of proportionality. So how did we say, what was that formula I could use to find constant of proportionality, or K? K equals Y divided by X. Now, because they're telling me this, we're looking for a constant of proportionality, I know this is a proportional relationship. If I plotted these points, because it's proportional, if I plotted those points on a graph and made a line out of it, will that line go through the origin? Yes, because proportional relationships go through the origin. And I know it's proportional because it has a constant of proportionality. They're telling me. We're going to prove that it does. All right, so Y divided by X. First thing, I want to look at my first ordered pair. What is my Y value? -3 divided by, what is my X value? So my constant of proportionality is -3. Now, in order for it to be a constant of proportionality, I have to get that same constant of proportionality for every ordered pair. For it to be proportional, for it to have a constant of proportionality. So let's double check and make sure. Let's look at the next ordered pair. K equals Y divided by X. What's my Y value? -6 over 2. What is my constant of proportionality? -3. We're looking good so far. We're matching. It's constant. It's staying the same. So I know it's proportional. Let's look at the next one. K equals Y divided by X. My Y value is -9. My X value is 3. What's my constant of proportionality? Did you get -3? All right. 2 more to go. Hopefully they work. K equals Y divided by X. What's going to be my division problem for this one? -12 over 4. Do I get -3? Yes, -3. All right, last one. Y divided by X. -15 divided by 5. I get -3. My constant of proportionality was the same, so that proves, yes, this is proportional. What that constant of proportionality, remember, on the front side, I told you that a proportional relationship could be Y equals K times X. Remember when we talked about that? So this K is that magic multiplier number. That K means I could take my X value times my constant of proportionality, and I should equal my Y. We can double check. My constant of proportionality is -3. 1 times -3. Do I get -3? 2 times -3. Do I get -6? 3 times -3. Do I get -9? 4 times -3. Do I get -12? 5 times negative 3, do I get negative 15? Yes, I do. Sometimes they're pretty easy. You might have been able to look at this and figured out this process or this constant of proportionality. What do you think would have happened if maybe one of these I got a different answer? Then what? Then it's not constant, is it? Then that means if it's not constant, it's non-proportional. That's all that means. If it's the same, it's constant, it's proportional. If they're not the same, then it's non-proportional. And we're going to talk about those kind tomorrow. Okay? So sometimes we have to prove that it's proportional on a table. Sometimes they give us a graph. The graph is just as easy. Because I have x values and y values in ordered pairs, don't I? All right. So the first thing we want to do is we want to pick pretty points. What do I mean by pretty points? What do you think that means? If I said pick pretty points on this graph. Exactly. A pretty point is where when it intersects x and y perfectly, it intersects at that cross. So let me blow this up. If I were to use this point right here, is that a pretty point? If I were to use that one? No, because it's in between. A pretty point would be like where if I go up at 3, do you see how it's right there where they cross? That's a pretty point. The reason why we want to use pretty points is because if I had to estimate, sure, this one looks pretty easy that it's right in the middle, but this one right here is just barely above. That's a little bit harder to estimate. So if we use nice pretty points, we don't have to estimate. All right, so we're going to use this point. We want to find the constant of proportionality. What's the formula for constant of proportionality? Y divided by x. So on this point, what would be my y coordinate? You got 1.5? What is the ordered pair here? The ordered pair here is 3, 1.5, right? I went over 3, up 1.5. So my y value is 1.5. My x value is 3. Use your calculators. 1.5 divided by 3. Use your calculator. Make sure you're dividing 1.5 divided by 3. Do you agree with his answer of 2? No? What did you get? 0.5. You did it backwards. You did 3 divided by 1.5. So that means my constant of proportionality, if I take my x value of 3, I multiply it by my constant of proportionality, I will get 1.5. 3 times 0.5 will give me 1.5. But now, if this is proportional, it should be true for any point on this line. So let's test it out. Let's pick another pretty point. What about if I did 5? I'm saving that one that you just mentioned for a reason. What if I did 5? K is equal to y divided by x. So this ordered pair would be 5, and what was the y coordinate? Go all the way over, 2.5. So what's my ratio that I'm going to write for constant of proportionality? 2.5 divided by 5. Do I get a matching 0.5? Are you sure? Did you use your calculator? Yep. 0.5. So that's that magic multiplying number that I multiply this by my x coordinate or x value, and it gives me the y. Now, remember when I told you back in 6th grade, we talked about unit rates, and I told you that the constant of proportionality is the same as a unit rate? What is unit rate trying to find? It's the amount for how many? Just one. Well, look at my graph. If I'm looking at one pizza is how many pounds of cheese? 0.5. That's the same. My unit rate is the same as my constant of proportionality. So if I had a graph that had a pretty point at 1, could I just use that to find my constant of proportionality? Why not? They're the same answer. But I would get the same answer, right? Every time. Because if I was doing the y over x, if I'm looking at my unit rate at this point, my y over x, y value is 1, x is 0.5. What is 1 divided by 0.5? 0.5. It works every time. Okay? But sometimes they don't just give us the picture or the table. They kind of put them into word problems. So let's flip the page, and we've got 3 little word problems that we want to talk about. All right, the value of y varies directly with x. First thing, I noticed this right here. Y varies directly. If it varies directly, is it proportional? Yes. What you do to one, you do to the other. What happens to the x results in the y. Whatever you multiply to the x, you get the y. It is proportional. So they want to know if x is 2, y is 15. So that's like an ordered pair, 2, 15, right? If x is 2, y is 15. That's an ordered pair. But they want to know if x is 8, what is the next y value? Well, do I want to draw a graph like on the page before? I don't want to freehand a graph. That's not my specialty. But look, if I have x and y's, could I just make a table? Let's do that. So let's make a table. X, y. And let's plug in what we know. When x is 2, what is my y value?
15.
It is 15. When x is 8, they want to know what is the y value. So I need to figure out what is that constant of proportionality. What number can I multiply by 2 to get 15? Right? But did the question ask for the constant of proportionality? No. The question asked for a final answer. What is y? They didn't ask me what was that magic multiplier number. They asked me, what is the y? A final answer. Well, we already said if it varies directly, it's proportional. Yes? Can I just set up a proportion? I know how to do those. We got to remember from 7th grade. If I set up my proportion, maybe I'll go ahead and use x over y. All my x's on top, my y's on bottom. I could use x over y, but I chose y over x just because I know it matches constant of proportionality. Kind of makes it the same. So I could set up 15 over 2, y over x, is equal to, well, instead of a question mark, what do we normally put in a proportion? A variable, x over 8. How would you solve this? We got to think way back to 7th grade. In 7th grade, cross products. In 7th grade, you would have went 2 times x is equal to 15 times 8. Well, what is 15 times 8? So you would have 2x is equal to 120. How do I solve for x? Divide by 2. Divide by 2. X is equal to 60. So that means x, the value of x, would be 60. Now, what if I told you that there was maybe an easier way that I could have solved this without having to do this whole equation? Would y'all be interested to know it? All right. if I'm looking at this, I know it's a proportion, yes? But isn't that also the same thing as equivalent fractions? Two fractions, they're equal, they're equivalent. So, and we're talking about multiplication. Let's see if there's some easy multiplication going on. How did the 2 become an 8? Times what? Times 4, yes?
I'm going to leave the meeting and going back to keep that moving.
Sure thing. And then we know if it's proportional, what you do to the bottom? Do to the top. What is 15 times 4? Bam, same answer. So I've shown you 2 ways to solve that proportion. 6th grade, you learned how to do them like this. 7th grade, we focused on equations. Well, now you're in 8th grade, pick which one you like better. All right, let's look at the next one. The number of holiday wreaths Sammy can make varies directly to the amount of fabric Sammy has. Sammy uses 32 yards of fabric for 4 wreaths. How much fabric will Sammy need for 10 wreaths? So again, the number of wreaths is what varies directly. So that's going to be my y value. X, y. So if I had to put a label on it, because I have to know which numbers go where. Whatever varies, remember the word vary means to change, right? Whatever changes is always your y value. So this would be the number of wreaths. And this would be the amount of fabric. So now I can tell which numbers go in which side, which is an x value, which is a y value. So Sammy uses 32 yards. Is that an x value or a y value? X. So 32 yards makes how many wreaths? 4. How much fabric? I don't know the fabric. To make 10 wreaths. Is it right now, is this question asking for constant of proportionality or a final answer? How much fabric will Sammy need to make 10 wreaths? Right now, I'm only looking for the final answer. I covered up that part that you were looking at. So I'm looking for my final answer. So that's just a proportion. All right, let's set it up. I can keep going with the y over x. Makes it easier. Everything is the same. So 4 over 32 is equal to 10 over x. Because I don't want to put a question mark. I want to put an x. All right, do we want to solve it with equations or do we want to look and see if we've got an easy way? All right, let's look at an easy way. First thing, I'm going to look across. 4 times what gives me 10? 4 times what gives me 32? Ah, 8. There's an easy multiplication. Times 8. But what I do to one side, I got to do to the other. Times 8 gives me 80. So my final answer would be 80. Could I have done the cross products and the equations and get the same answer? Absolutely. But why would you do that if you can find an easy way to do it? Now, that's one way they might ask the question. They might also give you this same information, but instead of asking for the final answer, they may say, what is the constant of proportionality? Well, since I have my XY table set up, all I got to do is plug it into the constant of proportionality formula. So how do I find constant of proportionality? K equals y divided by x. Remember, constant of proportionality is that magic multiplying number, right? Is 80 a magic multiplying number going across? It's not. It's not saying what I did to the x to get y. Constant of proportionality does. All right, so my y value, I'm going to go back and use what I know. 4 divided by 32. What is 4 divided by 32? Better double check your calculators. 4 divided by 32. 0.125. It has to be smaller. I'm not doing 32 divided by 4. It's not the same as what's going up here, because this was going from y to x. This is going from 4 divided by 32. I'm actually doing my straight division. So my constant of proportionality is 0.0125. That means, since it is the constant of proportionality, please put your phone away, that means I should be able to take 32, my x value, times the constant of proportionality to get my y. So if I take my x value, 32, I multiply it by my constant of proportionality, do I get the y value? Double check it. 32 times my constant of proportionality, does that give me y? Yes, it does. That's how you could double check. Remember, the constant of proportionality is that magic multiplier to go across my table. It's that magic number that raises up my graph. All right, last one, and then we'll be done. The cost of a pizza varies directly as its length of its diameter. So the cost of pizza varies directly. So what's going to be my y value? The pizza cost or the diameter? The pizza cost. And remember, I told you already, money was always y. Yes?
Your recording thing is like frozen, I think.
It's still going. I can see it on my end.
Oh, you're still on number 2 for me.
I'm on number 3. Your screen may be frozen. If you need to get out and get back in, go ahead. So then that means x has to be the diameter of the pizza. So we know a 12-inch diameter cost $8. 30 inches is going to cost how much? My first question up here in the problem is asking for the diameter cost for 30 inches. So it's looking for a final answer. Final answer, we need to set up a proportion. We can still set it up y over x. So what's going to be my first ratio? What's going to be my first fraction? 8 over 12 is equal to x over 30, because x is what we're looking for. Or it's the variable x, not x value, the variable x. All right, do we want to check the easy way? 12 times what gives me 30? All right, let's check up and down. 8 times what gives me 12? If nothing works, you got to do the equation. Cross, multiply, and divide. So I'm going to take 12 times x. 8 times 30. 240. So 240 divided by 12, because I need to get rid of it. Cancel it out. So x is equal to 20. So it would cost $20. $20. But then the question could say all of that information about a pizza, and then they just want to say, what's the constant of proportionality? They don't care how much it costs. They want to know, what is that rate of change? What is that ratio? So again, k equals y divided by x. If I did not have to solve all of this, all I had is my table. Remember, in my table, I wouldn't have this 20 here yet. So I need to use the x and y values that I have a full set. So 8 divided by 12. What is that magic multiplier number? Constant of proportionality. What is 8 divided by 12? So 0.66 repeating. That's my decimal answer. What about, because it rounded it. What if it was a fraction answer? What is 0.66 repeating as a fraction? 2/3. So my constant of proportionality could be listed as either of those, depending if your answers were in decimals or multiple choice. All right, take a moment and glue this in your spiral. You have no homework tonight.